Here's a question that confuses chemistry students all the time. If you dissolve 1 mole of salt in water, does it matter whether you measure your solution by volume or by weight? Sounds like a tiny difference, right? But it actually changes everything. And understanding why is the key to mastering solution chemistry. Here's the critical difference that makes chemistry students go, oh. Molarity uses the total solution volume that includes both the water and the dissolved salt. Molality uses only the solvent mass, just the water. So when you dissolve salt in water, the solution gets slightly thicker. The volume might be 1 liter, but that includes the salt particles taking up space. This means molarity is always a bit lower than molality for the same solution. And here's the beautiful part. Molality never changes with temperature, but molarity does. Want your solution to stay the same concentration? Use molality. Need to account for temperature changes in your lab? Molarity will betray you. Let's make this concrete. Imagine you're dissolving glucose in water. You have 1 mole of glucose and 1 kilogram of water. That solution is 1 molal. Easy. But when you add that glucose, the solution volume becomes slightly more than 1 liter, maybe 1.05 liters. So your molarity is 1 divided by 1.05, which is 0.95 molar. See? Same solution, different numbers. Now imagine it's a hot day and the solution expands to 1.1 liters. Your molarity drops to 0.91. But your molality? Still 1 molal. The mass hasn't changed. That's why biochemists love molality. It's reliable across temperature changes.
So when do you actually use each one? Molarity is everywhere in general chemistry labs. It's simpler for quick mixing because you just measure volume. Most stock solutions list molarity. But molality shines in colligative properties: freezing point depression, boiling point elevation, osmotic pressure. Anything that depends on the number of particles in the solvent specifically needs molality. Biochemistry labs often prefer molality because body temperature is constant and they're measuring precise molecular interactions. The real insight? They're measuring the same thing, concentration, but from different angles. Molarity asks, how crowded is the total mixture? Molality asks, how crowded is the solvent? Both are useful, both are right. You just need to know which question you're asking. So here's what we've learned. Molarity measures moles per liter of solution. Volume-based, temperature-dependent, perfect for labs. Molality measures moles per kilogram of solvent. Mass-based, temperature-independent, perfect for precise chemistry. The beautiful thing about chemistry is that the same concept can be described multiple ways, and each way reveals something different. Molarity shows you the crowding in your container. Molality shows you the true molecular environment of your solvent. Neither is wrong. They're just asking different questions about the same solution. Next time you're mixing a solution, ask yourself, do I care about volume or mass? That single question tells you everything you need to know.